Hello. So I would like to review the midterm exam quickly. The first two questions are pretty simple, so there is nothing much I would like to say. But let's think about question three. I tried my best to give you some points. I tried to make easy question that so that you can try, but it was very disappointing. So let's think about question three. The criterion function is the log likelihood function. So this is clear. So I would define the log likelihood function as log of fxi lambda. So this is obvious, but and so then I will put it here. Then you can write it as log lambda minus lambda xi. So here, this is not all. This is just a log likelihood function, and then the population criterion function is q0 lambda that in our notation is this, and the sample criterion function is the sample average. So I find that still many students do not distinguish the population and the sample. It's a serious problem. So the population, you may replace the term with true. So I explained it as the case where when you have infinite number of observations. So some of you try to explain it as a limit when n goes to the infinity. That is not wrong, but that's not the usual typical that's not the standard or not the definition we use. And so in the population criterion function, n does not appear. N is not of our interest. And then this means it is expected value of lambda, the log likelihood function, and then you have to rewrite which means like this. So the criterion function, the true criterion function, can be written in this way. So I have taken expectation, and lambda is non-random, and x is random. So only x is affected by the expectation, and now to show that the true parameter lambda 0 is the unique maximizer of Q0, you have to show two things. First, you have to show that lambda 0 expectation xi is 1 over lambda 0, or so you have to integrate this function. This is the definition of expectation. So it is not that difficult. You can use integration by parts, and then you can find it equals to 0. So the true parameter can be written in this way. or lambda 0, the true parameter is the inverse of expected value of x. And then now, so this is one thing. So it tells you that the true parameter equals 1 over the mean. So most of you do not show what is the true parameter. So lambda 0 is, so, and many of you only did that. So, and second thing you have to show that is the maximum of Q0 is satisfies the first order and the second order conditions. Most of you have done this well. So if you differentiate the parameter the criterion function, you obtain this first order condition, which means is the maximum. So what it says here is, so there are these are different. We obtained this using the PDF and like calculating the mean using the PDF, the probability density function. So this shows the true parameter equals 1 over expected value. And this shows what we obtained here is this is the value of lambda that satisfies the first order condition. So which is the maximizer of the criterion function, and the maximizer happen to be the same as the true parameter. So this is why the true parameter, the maximum, is the true parameter. Because the second order condition is satisfied, this is the unique maximum. Only one student have done this, and other, like all of you, have no idea what you need to do. So that was very disappointing. And then in the sample counterpart, it's easy. Sample criterion function is this, and the estimator, the estimator is 1 over x bar, where x bar is the sample mean. So sample average. So you may like it's the first order condition can be obtained in the same way, just using the sample counterpart, and it is easy. All of you have done this well. But now the consistency is not a big problem. It is fine. You need to check the ID condition and uniform convergence conditions, and there are some sufficient conditions for them. And finally, derive the asymptotic variance of the estimator. Asymptotic variance. There are many different ways you can use to show its asymptotic variance. One of the students, one of the answers that I liked very much is using the delta method. So you may use the delta method. So the first method is to show that is using so we know this is by the CLT. So by the central limit theorem, we know this is the standard central limit theorem. It converges to, so I will, where sigma squared is variance of x. And because we know the PDF, we can calculate so you can calculate the variance directly. So like for example, the expected value of x squared is the integration. You need to integrate this. Also, you can do this by integration by parts. So, and if you do this, maybe I think you get something like this. Or what you can do here is so let me do this exponential distribution Wikipedia. If you don't want to do the integration, you may simply go to Wikipedia and find the variance is 1 over lambda squared, right? The same PDF. So lambda squared is the variance. 1 over lambda squared is the variance. So this is lambda squared. You may calculate sigma squared, or it is not that difficult. And but I'm not so confident if I can integrate this well. Anyhow, if I have time, I can do. Try this by yourself. And then what I wanted to tell you here is knowing this, so from this, applying the delta method will give you, so the delta method is g of bar x minus g of expectation x it converges to g prime expectation x squared 1 over lambda. This is the delta method. So you are applying, and in our case, gx is 1 over x. So we are taking 1 over x bar and 1 over expectation of x. So then you will obtain the derivative. You can calculate the derivative, and applying expected value of x equals to 1 over lambda, then you may calculate the variance. This is the first method. And second method, you can claim that the Fisher information, like from the maximum likelihood theory, we know that the Fisher information is the asymptotic variance. Inverse of the Fisher information is the asymptotic variance. In this case, the variance is asymptotic variance is calculated as the derivative squared. So the squared function, a squared score function. This is right, and of course it's inverse. If my memory is correct, it's fine. This is correct, but the problem here is I think some students wanted to say this, but does not say anything. I did not teach this. I did it. It is true. There is this theory, but I did not teach Fisher information in this course. So if you do not say how you get to this formula, I don't know. I don't know if you understand the Fisher information or if you are misunderstanding the material. So I deducted points if you do not mention this part. No one mentioned it, and then I think that is wrong. You have to say how you get the formula. And the third method is to use the formula we used in class. H inverse omega H inverse. Then of course you have to multiply H inverse, and omega is this, and actually it is cancelled out. So in the end, it does not matter. The three method will give you the same result, but you have to be clear what method you are using, and otherwise, I don't know if you understand it or not. So I deducted a lot of points of yours. And question 4. Question 4. Question 4 is just by the way, I make up all the questions. I don't want you to memorize the materials. So I try to give you how the theory can be applied, because I may make up theoretical questions, but I know that then you don't understand what they mean, and you don't know. You just copy the lecture note, which does not help your understanding at all. So I intentionally twist the questions a little bit, and here let's think about this. So like the first question is simple, and the moment functions are so this is the moment function. You have two moments defined by. So let me rewrite this. So this is the moment function, or okay, many of you made many of you wrote down the are correct in this, but it may be also helpful, or it is more convenient if you define the so this is an alternative way to have the moment function. So by multiplying alpha plus 1 does not change the moment function, right? The moment function equals to 0, and multiplying alpha plus 1 to 0 does not cause any difference. So this will simplify your differentiation. So if you use alpha plus 1 in front of the first, like if you multiply alpha plus 1, then the derivative is also 2 by 1, can be written as this, which is also very simple. So a lot of things can be simplified by multiplying alpha plus 1, and then you may proceed with this notation. It does not matter which one you use, but I would suggest this is the best way, simplest way to answer this question. I did not want you to prove anything, and but many of you just literally copied the lecture notes, which shows you are not understanding anything. That's very disappointing. But I understand. You're I am used to that. Many students have the same problem. And what else? can I say? And also it is, and also I realize that still many students have no idea what they are doing. Like what is random and what is not. What is a parameter and what is unknown. What is a true value, and so their answers are going far away because of the small confusion, and uh, that's the biggest concern of mine. So I think I try to uh, comment on your answers, and like we try to read others, your friends, classmates' answers too, how they did wrong or correct, and your grade is not a problem. So don't worry about your grade. It won't be a problem, but worry about your knowledge, your understanding. So it is a chance to test your understanding and see what you understand and what you not. Uh, and that's the purpose of the exam. It is not. I don't think it as a kind of. So grade is not important. It is okay. That's all. See you later.